Today we are going to find the shortest distance from a point to a line. So how far is it from point -3, 2 to the line of y equals -x plus 7? So let's go ahead and let's plot that point and graph that line. So there we have the point graph. Now let's use the slope and the y-intercept there to graph out the line. So I'm going to graph out the y-intercept there is at 7. And then the slope there is at -1, so that's -1 over 1, so rise or run, so down 1 and 1 to the right. Now what we want to do is we want to find the shortest distance from that point to that line. You can have infinitely many lines you can draw from that point to that line. We want the shortest distance. So we're going to go through some steps to help us to figure out what that would be. So the first thing we want to do is we want to find the slope of the line, and then we want to find the slope of the perpendicular slope. Then we want to find the equation of the line using the perpendicular slope and given point, and then we want to find the intersection point of the two lines, and then find the distance between the 2 points. So let's go ahead and do that for our example that we started off there with. So the slope of that line we said was a -1. Now we're supposed to do the perpendicular slope. This perpendicular slope is opposite reciprocal slope. So what's the opposite of negative there? It would be a positive. And the reciprocal of 1, so if you take 1 over 1, you still get 1 over 1, which is 1. So our perpendicular slope there is just a +1. So now let's go ahead and write the equation of the perpendicular line. So we're looking at a slope of 1 and then that ordered pair of -3, 2. So I'm going to use y minus y1 equals m times x minus x1. My y1 there is 2 and my x1 there is -3. We've got a minus minus there going, so we're going to put a plus in there. If we distribute the 1 through on the right hand side there, we just get x plus 3 on the right hand side. And then we can go ahead and bring that -2 over by adding 2 to both sides. So our equation of the perpendicular line there is y equals x plus 5. Now we're supposed to find the intersection point of the two lines. So what you can do there is you can set the original equation, the y equals -x plus 7, equal to the new equation there of y equals x plus 5. And so the y values would have to be the same because we're looking for the intersection point. We can just say -x plus 7 equals x plus 5. And then what you want to do here is you want to solve for x. So I'm going to bring my x's on one side and bring my constants on the other side. So we get 2 equals 2x, because on the right-hand side we have a 1x plus a 1x gives us a 2x. So now we can just simply divide by 2. And we get x equals 1. So it's 1 something, so now plug 1 into one of those equations, it doesn't matter which one. I'm just going to put it back into the y equals x plus 5 equation. So doing so, I put 1 into that y equals x plus 5 equation. I put 1 in for x, and I got 6. So my equation there is 1, 6. I could have also used y equals negative x plus 7. If I put 1 in there, it would have been a negative 1 plus 7, which would be 6. So in either case there, I get the ordered pair there of 1, 6. Now I'm supposed to find the distance from 1, 6 to negative 3, 2. So if you remember your distance formula, you subtract your x's, square them, plus, subtract your y's, square them, so that minus and minus there becomes a plus, so we end up there with 4 squared, which is 16, and then 6 minus 2 there is 4, and we get a 4 squared, which is another 16. So we get 16 plus 16, and it's still a square root of that, so then we add those together, we get 32. Now we have to break down that square root. So what goes into 32? Oh yeah, 16 times 2. The square root of 16 there is 4, and then we're left there with the square root of 2. So 4 square root of 2. So let's just go back to our slide that we had previously there. So over here we had that negative 3, 2. And does it make sense there that our point of intersection there would be 1, 6?